Welcome to this explainer. Today, we're diving straight into a totally fascinating paradox in software engineering. We're going to look at why the relentless pursuit of so-called clean architecture actually leads to stalled development instead of, beautiful functioning code. If you've ever felt like your team spends way more time debating design patterns than actually shipping features, well, you are absolutely not alone.
Let's kick things off with this brilliant quote from our source article on Haber. It was written by a developer who clearly hit their breaking point, and honestly, it sets the emotional stakes perfectly. Today, pull requests have essentially become battlegrounds. Literally. Instead of colleagues helping each other solve business problems, they're fighting these holy wars over where a single file should live or whether an interface is truly necessary. It's frustrating, it's exhausting, and let's face it, it completely kills productivity. So here's our roadmap for today. We'll start with the illusion of clean architecture, examine the conflict between anemic and rich models, and look at establishing your team's law. After that, we'll discuss YAGNI and pragmatic review, dive into community practice, and finally, lock in on the idea that architecture is an agreement. All right, Section 1, the illusion of clean architecture. This is where we see what happens when architecture becomes a roadblock. You see, in practice, clean architecture isn't really a strict engineering discipline, not like structural engineering anyway. Instead, it's this collection of highly subjective concepts. Because every single developer interprets Robert Martin's books or domain-driven design completely differently, the architecture stops being a helpful tool. Instead, your development team basically transforms into a paralyzed parliament. Everyone is arguing passionately, but absolutely no work gets done. Moving on to Section 2, the conflict between anemic and rich models. We can call this the cat entity battleground. If you asked two developers to define a simple entity, let's just say a cat, you are going to get two incredibly fierce answers. Camp 1 is going to advocate for anemic models. To them, the cat is just dumb data, it's super easy to test, and the actual logic lives in a totally separate service. But then Camp 2 demands rich models. They want true object-oriented entities that manage their own state to prevent invalid data, and they usually view the anemic approach as completely outdated garbage. But here's the absolute crucial point. Neither approach is inherently wrong. You can build a wildly successful product with either one. The actual problem is that developers just can't agree on which one to use. As a result, you end up with what the author calls a schizophrenic codebase. Picture this. The users module is written with anemic models because one senior dev prefers them, but the neighboring orders module uses highly complex, rich models because another dev is a total OOP purist. Imagine being a new junior developer joining that team. It's like a patchwork quilt of personal preferences, and it will literally melt your brain trying to figure out which standard to follow. Which brings us to Section 3, the solution, establishing your team's law, or writing the team constitution. To fix this mess, the author provides 3 highly actionable rules for peace. It's a really clear framework to get your team actually coding again, rather than just endlessly arguing in the comments of a pull request. We're going to look at writing a team law, applying YAGNI aggressively, and completely shifting how we conduct code reviews. First step, stop looking for absolute truth in textbooks. You need a team constitution. You've got to gather the team and write down definitive, absolute laws. No wishy-washy guidelines allowed. If you all decide entities are rich, you write it down just like that. This document then becomes the ultimate judge. If a PR dispute pops up, boom, you just link to the Constitution. Sure, they can propose an amendment later on, but they cannot block a colleague's work today. That takes us into Section 4, YAGNI and pragmatic review, choosing pragmatism over dogma. This brings us to YAGNI on steroids. You aren't going to need it. Over-engineering so often stems from this deep fear of the future, like creating complex interfaces just in case we magically decide to swap databases 3 years from now. But listen to this. An abstraction that is not used is not an asset. It is a liability. You're basically forcing your team to pay a complexity tax today for a purely hypothetical future. Only extract an interface when you actually genuinely need a second implementation. Then we have step 3, which is all about fixing the code review process itself. We have to completely ban the subjective question, is this clean? It's just a matter of taste, and it always leads to fights. Instead, we need to anchor our code reviews to 3 highly objective, practical metrics. First, understandability. Can a junior developer read and understand this code without you having to stand over their shoulder and explain it? Second, changeability.
If the business wants to change one tiny condition tomorrow, how many files do I actually have to touch? If it's more than 2, well, your architecture is probably getting in the way. And third, testability. Can I write a simple unit test for this without having to boot up half of the application's infrastructure? Now let's dive into Section 5, Voice of the People, Community Practice. Time for a reality check. This tension hits really hard out in the real world. A user named OneIntrenits shared a wild story in the comments. They had strictly followed domain-driven design for an inventory system, and it resulted in a super sluggish 20 requests per second. The rich entities were just too heavy. Frustrated, they actually ripped out the clean architecture, shoved the logic straight into a database stored procedure, and guess what? Performance shot up to 420 requests per second. That's a 21 times increase. It really proves that dogmatic cleanliness can sometimes come at an unacceptable real-world cost. The community also fiercely debated that YAGNI rule, specifically around testing. The author claimed that creating an interface when you only have one implementation is a useless abstraction. Well, commenters pushed back hard on that. They argued, wait a minute, if I need that interface to create a mock for my unit tests, then it is being used. It's used by the production code and it's used by the test framework. This sparked this massive debate on whether functional testing without mocks is better, or if ripping out interfaces just makes your code super brittle to future changes. It really goes to show just how deeply personal testing philosophies can be. Another massive debate popped up around planning. Some commenters absolutely loved the evolutionary architecture idea. Don't plan too much up front, just let the architecture evolve organically as the product grows. But other, more battle-scarred developers warned against using startup speed as an excuse for having zero upfront planning. One commenter actually shared a total horror story of trying to untangle a 5-year-old minimum viable product that had spawned an exponential number of parallel processes, literally bringing the whole business to its knees. If you just code fast and break things without basic cohesion principles, you don't get an evolutionary architecture, you just get a swamp. And that brings us to our final part, Section 6, Architecture is an Agreement, the conclusion. So, looking at all of this, we really have to ask, who is actually right here? Is it the developers writing purely functional code, the rich model OOP purists, maybe the YAGNI minimalists? Or is it the pragmatic engineers moving logic straight to the database to squeeze out 21 times more server performance? The crucial takeaway from this whole explainer is that there is absolutely no universal right answer just floating in the ether. Architecture is not some magical book of spells written by industry gurus that will magically fix your project. Fundamentally, it's a human agreement. The only right architecture is the one that your specific team fully agrees upon, meticulously documents, and actually respects in everyday practice. So stop chasing academic purity, sit down with your colleagues, make the hard choices, and write them down. Then get back to doing what you do best, building amazing software. The next time you open a pull request, ask yourself, are you defending the business or are you just defending your own aesthetic? Thanks for joining me on this explainer. I hope it gives you a fresh perspective.